This is a demo of SD-Wire MicroSD Multiplexer. SD-Wire allows two devices to talk to one single microSD card, one device at a time, not concurrently. We tested SD-Wire with PinePhone as the test device, also known as DUT, device under test. And we connected SD-Wire to a single board computer as the test server. The single board computer we used is the Yuzuki Avaota-A1 by Pine64. Why are we doing this? For the Apache NuttX real-time operating system, when we review any new code and pull requests for the ARM64 platform, we need to test the new code on PinePhone. What if we could create a test bot that will test the new code automatically on PinePhone with little help from SD-Wire? Let us find out. We are looking at three windows here. Top window shows the Linux log from DMESG. It plays the kernel logs from our Avaota SBC. Middle window is the Linux command prompt from our Avaota SBC. We will run commands here to control the SD-Wire multiplexer. Bottom window is the UART debug output from PinePhone. This is coming from the serial debug cable that connects to the headphone jack of PinePhone. SD-Mux Control is the open source tool for controlling SD-Wire. We list the SD-Wire multiplexers. It found one. Let us control this multiplexer. DUT means device under test. DUT will flip the microSD to the test device, which is our PinePhone. TS means test server. We specify TS to flip the microSD back to our test server, which is our Avaota SBC. Cool, our SBC has detected the microSD. The microSD is now at SDA1. This means we can mount the microSD at /dev/SDA1. We can copy files to the microSD, like the NuttX image for PinePhone that we have compiled. Assume we have copied the NuttX image to the microSD. We flip the microSD to our test device, which is our PinePhone. Remember our microSD at SDA1? It disappears. Our microSD is no longer accessible from our SBC, which is what we expect. Now let me power up our PinePhone. We can use a smart power plug connected to PinePhone's USB port. I use IKEA Smart Power Plug controlled by Home Assistant API, so our test bot can power up PinePhone automatically by calling the Home Assistant API. Remember, microSD is now flipped over to PinePhone, and we see PinePhone booting NuttX from our microSD. Yay, it works! Now watch what happens when we flip the microSD back to our SBC. We run SD-Mux Control, flip it back to TS, which is our test server, our SBC. MicroSD now appears in our SBC as SDA1. This means PinePhone will no longer see our microSD. To verify this, we reboot PinePhone by cutting the USB power. Okay, I cheated here a bit. I had to remove the PinePhone battery because PinePhone will not power off immediately when there's some battery power remaining. PinePhone now boots Linux, but it is a little wonky. PinePhone battery is almost empty right now. Linux will not boot correctly unless the PinePhone battery has been charged to a minimum level. We flip the MicroSD back to PinePhone, and it boots NATEX once again. NATEX boots OK, even with an empty battery. And this is how we will use SD-Wire MicroSD multiplexer to boot and test the Apache NATEX real-time operating system on PinePhone.